Example 2. In this example, we are told that an investment of $60,000 today will generate payments of $30,000 in 1 year and another $40,000 in 3 years. We're asked to determine and compare the net present value of the investment at annually compounded interest rates of A, 6%, B, 10%, and C, 7.6%. So we're going to see how interest rate affects our decision making or our conclusions. In all cases, the time diagram will be the same. So let's get the time diagram out of the way. We will set up that time diagram and then take a look at what we have to do. So let's start off with the money out. And so the money that goes out of our pockets is what we spend today, which is going to be $60,000. So we will be out of pocket $60,000 today. Now let's compare that to the money in. And the money in, we'll put that on the opposite side of the time diagram. So at the end of 1 year, we will get income of $30,000. And subsequent to that, at the end of 3 years, we will get more income, another payment of $40,000. So if we just look at the face value of things, we get total income of 30 plus 40 or $70,000 over time. And in return for that income, we have to pay $60,000 today. So on the face of things, it looks as though we're making a $10,000 profit. But our $10,000 profit is only relevant if we are satisfied with the rate of return that we are earning on our investment of $60,000. So what we need to do is to compare the net present value of this investment by comparing the present value of the money in and subtracting from that the present value of the money out. So the net present value of our investment is the net present value of the income minus the net present value of the outflow. Okay, money in, subtract money out. Well, what's the present value of the money coming in? Well, the present value of the money coming in is the discounted value of the $30,000 discounted over 1 year plus the present value of the $40,000 discounted over 3 years. And in the first case, when we're going to be solving this, calculating the present value using 6% compounded annually, that means that IY is equal to 6% and CY is equal to 1. And the nice thing about this is that n is equal to 1 interest period in the first case, and n is equal to 3 annual interest periods in the second source of income stream. So we can use our calculators and the built-in functions for these present value calculations. So let's step aside and do the calculations. And so you see the calculations here that at 6% compounded annually, the present value of the $30,000 plus the present value of the $40,000 adds up to a total of $61,867. I'm going to round that off to the nearest dollar. And I subtract from that the present value of the money out. That leaves me with a net difference of $1,867. So if my desired return on my investment is 6%, then this investment is actually paying me a little bit better than 6% because I'm getting a net profit of $1,867. I'm ahead of the game by $1,867. Now let's compare it to the return on our investment if I was wanting a desired rate of return of 10% compounded annually. So the only thing that I'm going to change here is the interest rate in the present value calculation. So I'm going to substitute the 6% compounded annually with a number of 10% compounded semi-annually. So I'll give you a moment to work on that. And so at 10% compounded annually, the present value of our income minus the present value of our outflow is $30,000 discounted at 10% for 1 year plus the $40,000 discounted at 10% for 3 years. That gives us a grand total of $57,000, $57,325. I'm rounding off to the nearest dollar, and I subtract from that the present value of my money out. That means that my the present value of the money in is actually less than the present value of the money out using an interest rate of 10%. So in other words, this is a losing proposition if I wanted a return of 10% on my money. So this investment is actually giving me less than 10% return on my money because my income has a present value that is less than my outflow. So it's a losing proposition at 10% compounded annually. So I would certainly not invest in this proposal if I wanted a 10% return on my investment. But I would invest if I was satisfied with a 6% return on my investment. Now, in the last analysis, what I'd like to do is to consider the net present value of this investment using an interest rate of 7.6%. And so at 7.6%, the net present value of my income is the present value of the 30,000 plus the present value of the 40,000. And from that, I subtract the present value of my outflow. And that gives us a grand total of 30,000 discounted plus the 40,000 discounted is 59,990. We'll round that off to the nearest dollar minus the $60,000 outflow. So that gives us a net present value at 7.6% of a value of negative $10. So what does that tell you? That they're almost the same. They're almost equal. The present value of my money in is almost the same as the present value of my money out. So what this tells you is that the investment return for this investment is very close to 7.6%. In other words, at 6% we were ahead of the game. At 10% we were behind, we were losing money. At 7.6% we're neither making more or less. In other words, the present value at 6%, at 7.6% matches the income, matches the outflow. So that means that our rate of return on this investment, on the $60,000 investment, is very close to 7.6% because the money in is equal to the money out, or almost equal to. So if I'm satisfied with a 7.6% return on my investment, then yes, I should invest my money here. And 7.6% is a very good return on one's investment. So I would accept this investment at 7.6%.